No, it's
Hello.
okay.
Hello, welcome to today's webinar. This is Freda from DJI Enterprise team. We'll just wait for a few more minutes, like 2 minutes, for more people to get joined. Can you guys see my screen right now?
Yep, there we go. Yep.
Yes. Oh, good.
Good. Okay, let's just wait for maybe just 1 more minute and then we'll start. All right, hello, good morning and good afternoon, everyone. Welcome to today's webinar. This is Freda. I'm leading the overseas solutions engineering team in DJI Enterprise. And DJI L2 is our new LiDAR payload that we have introduced in October last year in the InterGeo event. And it was found to be really a great tool for AEC and construction. And we're going to talk about how a few very interesting L2 case studies in the UK, what value has been created, and also the workflow of using the DJI L2. So in today's webinar, we have invited Alex Williams, who is the technical geospatial specialist at Heliguy, one of our leading channel partners in the UK. Alex has a master's degree in GIS and also had working experience previously in the infrastructure planning industry. So if you have any questions during the webinar, please feel free to put it in the question box. And we'll also have a live Q&A session at the end of the presentation. So, and also we'll be sending the webinar recording to all the registrants after the webinar, so don't worry about it. And before we go on to the details, just to share the webinar outline. So we'll begin with one case study about how L2 has increased efficiency and the accuracy during the Everton Stadium development. And also another one with our client, Murphy Geospatial, how they used L2 in another construction project of the HS2 highway. So these will be two interesting case studies. And also Alex will be talking about the detailed L2 data collection and data processing workflow. And the last part, I will be talking about a few major new updates, including the new features that we have added in DJI Terra on the LiDAR data processing. So that will be the main contents for the webinar today. And Also, before we get started, just a quick poll to allow us to understand more about your role, and also that we can potentially try to, accommodate your needs. So you can take just a few seconds to select the option that best describe your role. Not sure you're a drone hardware reseller or service provider or an engineer working in the construction industry. So let's quickly, just a few seconds, and we will close the poll. And so we can see the results here. So Alex, looks like half of our audience today are surveyors and 20% drone service provider. Great. Thanks again for joining the webinar. And so I guess we can get started. So over to you, Alex.
Okay, great. Right, can you see my slides there?
Yeah, I can.
Yep.
Oh, sorry, 1 second, maybe. Yeah, it's okay.
Yep, that's okay. Right, so good afternoon, everybody. So we're going to be looking at how the L2 can improve your workflows in the architecture, engineering, and construction industries. So without further ado, let's begin. So a quick word on myself. So I'm part of the geospatial team here at Heliguy. So I've got my main role here is support on LiDAR and photogrammetry, with a bit of guidance on GNSS principles and any sort of data software that you might be using. So just a little bit of background on me then. So the geospatial team here at Heliguy, we're mainly focusing on sort of helping clients set up drone programs. So we try to provide the GIS knowledge, the surveying knowledge, so that they can go forward and set up their program and can get the relevant outputs from software and be able to get their accurate data. So we often deal with something called the drone assisted program, where we might, as part of a sale, go and demo, say for instance the L2, go and capture some data for them, show them how to collect that data, process it, and what they then can do with it. So we move on to the case studies. So we have two major ones to discuss today. So the first one is Everton's new stadium. So we've been working with Select Plant Hire, which are a subsidiary of Lang O'Rourke, and they've been using LiDAR data to monitor the construction of the new stadium and the infilling of Bramley Moor Dock. So there's been some land reclamation being carried out there in order to build the area for the stadium. So measuring the vast quantities of sand has been a real key issue for them, and the LiDARs helped them do that in a much safer, much quicker and more efficient manner. And then the data has gone on to monitor the progress of the construction, and they've integrated it with various bits of software that they've been using to build a virtual model, and that's been put to shareholders to show fans, and really, you know, monitor it and give people something to watch over, and not only take just measurements and be used in surveying. So the second one on the right there is a section of HS2. So we've been working with Align JV, and they're subcontractor Murphy Geospatial. So they have a section, central C1 section of HS2 phase 1. So there's a 3.4 kilometer section through the Colne Valley, and they've been looking at flying both the L1 and the L2 and comparing the data you get from both, and using that to monitor the construction, extract features, use it for stockpile measurements, and things like that. So move on to Everton Stadium. You can see the point clouds generated from both sensors there. So we've flown this at 120 meters, and the crucial thing here is we've been able to verify the accuracy from DJI. So we've been able to show that the L2 has got absolute accuracy of 37 millimeters as opposed to the L1 54 millimeters. You can really see that the L2 data is much more complete. It's much more well defined along the roof structure. If you look on the seating areas, there's much less missing data there. The cranes are much more well defined, and overall it's a denser point cloud. It's more accurate. There's less noise. So we're really pleased with it. That's been backed up by the comments from our client. So there's a number of good quotes from them. So Aaron Scallion there, who's the head of Select UAV department, said they needed real-time information to monitor the sand levels as they increased, and LiDARs helped them collect this quickly and accurately on a daily basis and provide stakeholders with the key information. Since they've moved on to the L2, it's meant that they've been able to have a much more accurate model, and it's also been able to fly faster as well as capture data at a higher height and be just as efficient. So they've really been impressed with the L2 and its improvements. So there's not only has the LiDAR data being used, but they've got some other drone photography going on with things like the P1 camera. So there's a shot there from the stadium in mid-construction that can be used for their publications and really demo what's been going on there. So another couple of quotes there from Aaron Scallion, which we're really impressed with. So this has been mainly focusing on safe, efficient, cost-effective versus manual methods. And a word from Gareth Jacques, who's the project director at Laing O'Rourke. He's been saying that the drone footage has been vital for updating the fan base and clients. It's helped communicate what we were going to deliver and what has been achieved, and provides a source of reality compared to 2D drawings. So it's not only the LiDAR data itself, but all of DJI's products have been used in this case study and have gone on to make it a lot better. So sorry. So yeah, they've integrated their data into third-party software as well. So they've used Terasolid to classify the point cloud, and the post-processing has helped identify certain features within it and be able to mark out the building, mark out the ground surface, and that's helped go into a software called Synchro, which is where they've built their digital model. So what you can see there on the right is the classified point clouds from Terasolid. Now that's an automatic process that you can run through, but you can go in and further change that. So you could, for instance, classify those cranes. So you can see in the dark blue there, you might want to remove them from the model because they're temporary features. You can classify the ground surface and take out just a DEM, or perhaps you might want just the building itself. So that can all be manually done, as well as it can be manually adjusted after running through the automatic wizard. So at this point, I'm going to share the video that we've recently produced on the Everton case study and provide a bit more background information on that. So
This is the new Everton Stadium. It's the new home for Everton Football Club, and this will be a new, just under 53,000 capacity football stadium due to complete at the end of 2024. The project itself is great for the city of Liverpool. I always tell everybody that's coming to work on the project, you don't have to be an Everton fan to work here. It's creating opportunities way beyond the boundaries of this particular project. I'm Aaron Scallion. I work for Select Plant Hire and I look after the UAV department. So in the first stage of the project, we used the L1 to monitor the sand infill of the dock. Now we're using the L2, we've been able to see the key benefits coming through.
We've worked with Aaron and Select Plant Hire for the Everton Stadium project in order to help them use LiDAR as well as photogrammetry. We also do site visits to make sure that they're getting along with the hardware okay and getting the deliverable results from their data set.
We're using the drone technology quite extensively on this particular project. So as well as doing normal progress videos and update, we actually use it in our immersive suite, which is a digital area where we coordinate construction work, logistics, plant movement, craneage. We can look at our digital 4D model, we can look at our construction program in its traditional format, and then we bring the drone technology here, see where we are in terms of reality. So it gives us a complete spectrum in terms of theory, model, reality. So it's proved to be extremely effective.
So Aaron and the team at Select Plant Hire have used various data collection methods on the Everton Stadium project. They include nadir with the camera angle pointing straight down, oblique with the camera pointing at an oblique angle towards the facades of the structure, as well as a number of manual missions in order to capture data around features of interest.
The L2 has increased efficiency, gathering more accurate information and been able to process it faster through DJI Terra. We're able to get real-time, fast and accurate data on a daily basis. By using the L2, we're able to generate data for earthwork movements, including volumetric data. This is invaluable on the size of the sites that we have.
There are some clear improvements in the data quality from the L1 to L2. The improvements of the sensor mean that you can fly faster for greater efficiency and collect more accurate data even when flying higher. It has better vegetation penetration because it now has 5 returns instead of 3, and it also has an improved RGB camera, which means that you can have greater efficiency when collecting photogrammetry and LiDAR data. The team on site captured 5 flights, which lasted for a total of 35 minutes. They then took the data to DJI Terra and processed it into a standardized output so it could be imported into other software for further manipulation and processing. Some of the new features in DJI Terra include the capability to classify the ground data as well as produce a DEM from your LiDAR data.
Using DJI Terra, we were able to process large amounts of data on a very fast turnaround.
So when we processed the data in DJI Terra and in Terasolid, what we found is that the data was very clean, and when we compared it to our checkpoints, it was also very accurate to the coordinate reference system which we collected it in. So Heliguy has been working with Langer Oak for just over 4 years. During that time, we've assisted with regulatory training, workflow support, as well as hardware supply.
Heliguy has been very supportive in directing us into the latest technologies and helping us understand the benefits of the various drones on offer from DJI. So we're always looking at how we can improve our processes and our management tools. I'm keen to see how we can use the technology on a more internal basis. So we're now in the critical path of our program, which is running through the internal works. So internal partitions, walls, rooms, mechanical, electrical services. And traditionally that's harder to demonstrate digitally and in a model. So if we can have something equivalently as good internally as we have externally, that'll be the next big step forward. So I'm open to ideas.
Okay. So that brings us on to the next case study, which is work with Murphy Geospatial at the HS2 site. So Murphy have been using the L2 for measuring the ground surface. So this has been quite key with the L2, with it being able to penetrate further through vegetation with its 5 returns. And they've been focused on recording, power line data. So the fact that the L2 is now better at picking up small details, it has been key here. And then they're also looking at quantity surveying, so measuring materials on the ground. And that's been a lot more improved with the L2. So our contact there, Pedro de Gueva, is chief UAV pilot there, and he's praised the capabilities of the L2. He said he's been very impressed with the quality of the point cloud and the density perspective that has come from the L2 versus the L1. So you can see on those 2 images quite clearly that the power lines have been particularly well picked up by the L2. The structure of the pylon is a lot more well defined, and the wires are clearly marked with very little noise around them. If you compare that with the L1, you can clearly see that it's very intermittent in where it's picked up the wires. There's quite a few gaps on the pylon itself. So we're really pleased to see that the L2 has made those improvements. So looking at the actual improvements with the L2 versus L1, this particular case study, as we flew the area, the exact same area with both sensors, it was a great opportunity to really test the specs of the 2 sensors and see how they compared. So the increased returns of the L2 means there's the increased penetration through the vegetation. The laser reflects off each surface it encounters, and the L2 has the capability to detect 5 returns. So this gives a greater amount of points compared to the L1 and more chance of hitting the ground surface. The higher sampling rate has also improved things. So this has led to a greater point cloud density, and the increased likelihood of detecting small features due to the improved coverage that means. The L2 can also be flown faster. It can handle flights up to 15 meters per second, as opposed to the range of 8 to 13 meters per second with the L1. Now it might be preferable to fly slower with LiDAR to improve the point density, but it does mean that if you need a quick mission, that you need to fly quickly and get your data in the most efficient manner, you can now do that, and you can fly that at 15 meters per second. So the L2 also has a more concentrated beam. So this helps give more precise results. So the footprint of the laser will spread out from the sensor as it travels, just as if if you shined a torch at a wall, if that wall's further away, the the area of light will be larger. It's exactly the same for a LiDAR sensor, just on a much smaller scale. So this means that it's picking up less noise points, and it helps to give you more defined target features. So the L2 is also has a better detection range. It can detect objects at 50% reflectivity, while the L1 needs 80% reflectivity. So that's both from 450 meters, which means you're going to be able to pick up more surfaces, and it can be flown higher and achieve better results. So the L2 also has a improved RGB sensor. So this leads to improved colorization of the point cloud, and you see a more true to life model from that. So looking at DTMs produced with both sensors, so these were produced from QGIS just to illustrate what's going on with the two sensors and how much better the data is from the L2. So you can see that areas of vegetation, in that sort of central right area of the model there's much more coverage of the ground surface there on the L2, and that is really down to the returns of the L2. It's reaching the ground surface and getting a much more robust surface produced, and you're having to do less interpolation with the data to get that DEM. So this is all helping make better decisions as you're getting much more accurate data. So this is a section through that area of vegetation on the model. It really illustrates what's going on here. You can see each return and the fact that it is reaching the ground surface. So you can see that the L1, there's quite a lot of gaps there on the ground, and you know, software would usually have to just interpolate across there. But with the L2, you've got confidence that you're getting the accurate data you need. So in terms of object detection, this is a really great screenshot for illustrating that. You can really see the detail that the L2 picks up on the pylons, and the improvements that have been made over the L1. So this is really down to that smaller beam divergence, its increased capture rate, and the overall improvements of the sensor. So at this point, I'd like to talk about potential other use cases, and I'll open this back up to Freda in a minute for another poll. But we've seen quite a few other use cases with the L2 through archaeology. People have been looking through the canopy to detect ruins, and that's often really great in forested areas. The L2 has shown to be much improved with that. For forestry, you can now map individual trees through other software, and the L2 is capturing much more data on those trees. You're seeing the full structure of each tree, and there's very little in the way of sort of gaps on that data. Through hazard management, we've seen examples through flooding and planning for that. So you can create very accurate DEMs and look to create drainage layers, work out where water is going to flow, and run simulations with that data. We've seen cases used in geology where people are interested in accurate models of slopes, mapping the volumes of material and looking, to use that point cloud data to assess, things like landslides. In infrastructure and asset management as well. We've had cases where it's simply been about marking certain features, knowing where they are, and the L2 with its improved accuracy is helping to gather that data and really, speed up the process in those kind of industries. So at this point, I'll pass you back, Freda, so you can just introduce this poll.
Yeah, sure. So change. Yeah, thanks, Alex, for sharing the 2 interesting case studies as well as the findings. So here we just want to have another poll to discuss a little bit on the potential use cases for LiDAR. So like Alex mentioned, we've seen definitely a lot of use cases for topographic surveying, utilizing the advantages of LiDAR, being able to penetrate through the vegetation and get the elevation data of the bare earth, as well as for construction project management. But also, like, for example, here in China, we've seen really massive applications of using LiDAR for, for reconstruction of the power lines, of the transmission corridors, and then being able to, for example, to measure the distance from the power lines to the vegetation, and also for the other kinds of infrastructure like bridge or substation modeling. So let's see what our audience think. So here you can see still, I think 70% of people think still they're mainly using LiDAR for land surveying, and also really for the other options, I think it's pretty much, average. So great. A lot of potentials for this, for the LiDAR technology, and also for the L2 product. So great. I guess we can then continue to talk about the detailed workflow of using the LiDAR technology. So I'm going to change back the presenter to you, Alex.
Okay. Okay, so now that we've gone through the case studies, and you're looking at how do you integrate this yourself. So this is a little idea of the kind of process that you might go through to start off a mission. So first of all, you want to ensure your operation is planned. Do your pilots have the GDC training? Do you have permission to fly in the area? So this particular sensor, you will need the M300 or the M350, which means that you will need in the UK the GDC training. So that's a sort of first step. Once you've planned your area, you've perhaps undertaken NOTAMs or gained the right permissions, then you can start to plan your flight via the Pilot 2 app on the controller. Now, this is a simple case of drawing the polygon over the map on the controller, or you can import a KML from something like Google Earth. It's important to note that all the firmware should be up to date on both the drone and controller, and that you will need an RC Plus for the L2. The next step will be to carry out your flight on site, following your risk assessments, etc. So this stores the data on the micro SD card in the DCIM folder, and a number of folders will be created for each mission dependent on the size of your survey. So these raw files then need to be processed in DJI Terra to get your sort of traditional point cloud formats like your .las files. So just looking at setting up your mission on the controller, it's a simple case of drawing the polygon there, selecting the payload and the aircraft, and then there's a couple of sort of key settings to look out for. So one of those is making sure that the return mode is set to pen to return. So that's to ensure that you're getting that penetration through the vegetation surface and really maximizing capability of the L2. It's also recommended there that you set the side overlap to 50%. This just ensures good data quality and that you're not missing anything when you're flying. So if we carry on, oops. So there's some other considerations to look into when you're setting up that mission. So you'll be asked for whether you want to do ortho or oblique collection. Ortho will be quicker, but it's less detailed as the sensor just faces in one direction. So oblique will take more time, but if you've got an area with things like building facades or any sort of vertical features, it's recommended to do oblique because you'll pick up more data there, as the sensor will automatically change angle to capture that information. So the next thing is looking at ground separation distance. Now this refers to the distance between points measured by the sensor. Reducing this results in a longer flight time, but at greater point cloud density. There's no fixed recommended setting for this, but it may be just a case of adjusting this a little bit on the fly, depending on your mission, depending on your needs. It will update the controller with a flight time, so you can choose what's best for you in that situation. So also in terms of speed, this is another one that will govern point cloud density, and although the L2 supports being flown at 15 meters per second, that's great for efficiency, but you might want to reduce this a bit to increase the point cloud density and capture more detail. So it is another setting that you can adjust, and it will update that flight time on the controller, so you can choose what's best for you in that situation. Another one to look out for is target surface to takeoff point. So if you've got an area, say, taken up by, for instance, maybe it's a large warehouse building, something like that, and it's covering a large part of your survey area, higher than the ground surface, then it's worth setting this to the height of that building. And this just helps with accuracy of your data, but it's only really for situations where you've got something taking up most of your survey area that's higher than the ground surface. So quite a specific setting, that one. So something else to consider is whether you're going to use RTK or PPK for your data. So you're going to need some way of getting satellite corrections to ensure that your models getting absolute accuracy. So we would usually recommend going down the route of network RTK. So if you're dealing with that, if you're using something like, I don't know, Trimble VRS, or perhaps our Ntrip service that we provide through Premium Positioning, you would go to the controller, and there's a little 3-dot symbol in the top right when you're planning your mission. And then it'll bring up this menu. If you scroll down to the little satellite symbol there, you can see in the bottom left. And then you can select RTK service type. If you select custom network RTK, and then you can input your credentials there. Alternatively, you can select a DRTK2 base station if you have one of those. Or if you're flying without RTK and you want to do post-processing kinematics, you'll then need to download RINEX data which will then be input with your raw data into DJI Terra. So let's have a look at how you might do that. So we would tend to use Ordnance Survey for downloading our RhinoX data, although you can get this data from third-party base stations. So this is a little bit of a just guide on how to do that with Ordnance Survey's website, where you'd search for your nearest base station, and then find the date and time of your survey from the first and last JPEG in your data. Make sure that the RhinoX data is going to cover that, and then you should be able to download a .240 file. Now, all you need to do with this when you're processing is add this into your raw data folders, and you'll need to rename it with the same name as the other text files that are in there, and then change that file extension to .obs, and that enables DJI Terra to read that data in. So, oops. So this is an example of what your data might look like when you download it from the drone. So you can see there's a whole pile of text files, which you don't explicitly need to understand all of these. The key one there is the RTB file. That will be what's generated if you've got network RTK on the drone. And then you'll see your JPEGs underneath there. So that's just a little bit of an explanation of what each file means, and it's usually just a case of making sure that these files are in, and this is what DJI Terra will turn into your traditional sort of point cloud formats. So at this point, I'd like to share my screen and just go through how you set this up on DJI Terra. So this is the software here, and if we go to new mission, select LiDAR point cloud, you can just call this just a webinar test. Now to add your data in, there's a little folder icon up here. So that will bring up just a directory here, and we can navigate to where our data is stored. So for instance, this one here was flown at our test site with Komatsu, and these two folders are for our Penta returns flight. So that imports in, and then you can begin to set the parameters for your mission. So I'd usually keep it on by percentage and keep it on 100%, and that just means you're going to get 100% of the point cloud there. So through point cloud processing, we've got options to conduct ground point classification. Most of these settings can be left on default unless you have perhaps quite a steep area, and then going through some of these tooltips on board the software, you can, for instance, change the iteration angle to 10 degrees if you've got a particularly steep area, and that will just help with the ground point classification. You can also select generate DEM. Now this can be done by GSD, so this can be taken down as low as 0.05 meters per pixel to give you the best resolution DEM possible. That might mean that the TIFF that is generated might be quite large in that case, and it might be a bit too fine for what you're doing, but that can be adjusted as you see fit, really. Contours can now be generated as well. That's quite a recent feature of DJI Terra. So there's intervals that you can set, and this will produce it as a .shp and a DXF file. So this is quite good for importing into CAD-based softwares or other GIS software that you might need. So if we go into advanced, you can import your GCPs into the accuracy control and check area. So if you import you can import a CSV here, and that is just a simple case of then naming the columns, and Terra will read those in and then adjust the model along the z-axis for any offset there. So you can then decide what coordinate system you want to set up your model in. So for this one, I'll just keep it in something simple for today with WGS84. And then you can set your point cloud formats that you want. So for most cases, .las will be what you want there. And then I'd recommend ticking merged output, just as this produces one LAS file rather than breaking it up into several different blocks. So once you've selected all those parameters, you can hit start processing. But I won't do that today. I'll just show you one I've set up earlier so that you can see what the software is capable of. So if I load up L2 Komatsu, so this is our demo site and where we've been able to test out the sensors ourselves. So you've got a number of options here on how you can display the model. It's from RGB through reflectivity of the surfaces. The height can be shown there. The returns is quite useful, particularly along areas of vegetation. You can see each individual return and how it's penetrating to the surface, with some of those red points there as the fifth return. So it's also possible to show it by type. So there we've got the ground points shown, and you can see how well Terra's picked out the ground surface in relation to other features. This contributes to the generation of the DEM, and you can really see the detail that can be picked up. So this was at 0.05 on the GSD, and you can really see very sort of fine detail features with it. So some of the other features you can do are the cross-sectional profiles. So we can draw profiles across our model and then see, we could take measurements here, so we can introduce grid lines, and then perhaps we'd want to measure the distance of this stockpile here. So that gives you the distances and it will pop up there. Or maybe we just want to take a coordinate. So we can do that. We can get latitude, longitude, and altitude for anywhere along that section. Likewise, we can do that with the measurement tools from the model as well. For instance, we can take the coordinates. We can measure a distance. We can measure an area. Or we can even do a volume as well. So maybe we want to measure this pile of material here. So that's just simply a case of drawing points around it and then just let that load. Right, my PC is just being a little bit slow there. Right, there we go. So you can see you've got a cut volume there of 766 meters cubed. Likewise, that can be done over, for instance, ditches or something like that, so you can calculate fill volumes as well. So I think that brings us to the end of what I want to show in DJI Terra. So I'll come back to the slides. Right. So after we've generated a LAS file in DJI Terra, we can then look at further processing. So an example software would be Terasolid. Now this is the leading software for point cloud manipulation. It allows for further classification of the point cloud. So you'll be able to pick out things like buildings and vegetation, things like power lines. You can set up classes as you see fit there and extract features using this as well. It also helps with cleaning the data, although we've seen that the L2 has very little noise. It can be run through Terasolid's wizards in Terrascan, and that will help to smoothen out the data and filter out any noise at all if there is any. So we can look at, there's an example of the Everton Stadium processed through Terasolid. So you can see that the roof structure there has been sort of classified in white, with the building's walls in light blue and the seating area in red. So it's also classified things like the cherry pickers there and the cranes as dark blue, as they're temporary and can be sort of removed out of the model. So this also just explains a little bit about Terasolid software. So what each feature of the software does, as it can be bought as separate packages. So Terrascan is processing point cloud from beginning to end, the highly automated mode. So that really lets you just import it into a wizard, and you can select from some parameters to suit your needs there. Terra Match is to do with strip adjustment, so it helps with data accuracy. But as I've said, you know, the L2 has been very good for this kind of thing. So there's been little that's needed doing to any of the data. Terra Modeler, so that deals with surface modeling tasks. So if you want to be able to generate surface models out of it, you may want to include buildings in that. You may want to, you know, remove certain classes. That is the package that you'll need for that. And then Terra Photo lets you take the best out of the images captured together with the LiDAR, with the laser data. So another option is to go through ArcGIS Pro. So this enables you to display the point cloud in 2D or 3D. It can be rendered as a tin model, and it can be visualized using elevation, slope, aspects. You can set up contour lines based on certain LiDAR filters. So there's a number of derivatives you can get there from the LiDAR data. And then a lot of the 3D analyst tools within ArcGIS can be used with the .las files. It also has features to further classify the point cloud. You can set up AI models and train them in this software. So for instance, if you have a particular type of feature that you want to classify all the time, you can tell the software what to look for there, and then you'll have a classification setup that will work for further surveys that you do. So here's an example in ArcGIS Pro. So there's a couple of things that you need to do when you're importing data into ArcGIS. One of those is to convert it to a LAS data set. Now there's a tool for this, but it's very simple. It's just converting the .las file into a format that ArcGIS handles a little bit better. And it just enables the display of more points there. And then you've got your options to show a bunch of the surface derivatives. You can do viewshed analysis with it. So that's quite useful if you're, for instance, we've had a client who does drone shows, and they've been looking at sort of where the drone show can be visible from, where it might have issues with safety and collide into features, so trees and things like that. So that kind of analysis is quite good in ArcGIS, and also you can do the volume calculations in this if you want. ArcGIS is also quite good for creating fly-through videos. So you can convert this kind of data to a scene layer package, and then that's also able to be uploaded to the web via ArcGIS Online. So that can be really good for sharing data and just being able to show off a particular area to someone who perhaps doesn't have this kind of software. Right. So that brings us to the end of the slides. So at this point, I'll hand back to Freda and we can continue. Oops.
Thanks a lot, Alex, for sharing the workflow. Really a lot of good stuff, I guess. And yeah, right. Actually, right at the beginning of the webinar, I saw in the question box an audience is asking, like, is the LiDAR data processing or collection a really complicated process? So I hope we have you relief right now. I hope like after Alex introduced the workflow, you will find that this is in fact a really like kind of a simple and really actually very straightforward process. Okay, so for the last part of the presentation, I'm just going to share quickly through a few major updates that we have come up with in the recent DJI Terra software update. So first of all, for those who are not really familiar with DJI Terra, just to give a quick overview. So basically, DJI Terra software is a photogrammetry and LiDAR data reconstruction software. So for example, what you can put into the software, including like DJI drone images taken by the M3E or P1 or any drone data with the with the GPS location, and then it can turn the images into 2D maps, 3D mesh models, or point cloud with photogrammetry calculations. And another new software that we have recently launched is called DJI Modify. It can, based on the 3D model created by DJI Terra, it can further do some model retouching. For example, like repairing water surfaces, as well as like removing the vehicles in the 3D mesh model. And on the other side, like Alex have mentioned, you can also feed the raw data collected by DJI LiDAR payloads like the L1 or L2 into Terra and produce the LiDAR point cloud like LAS or PNTS formats. And the other format that we also support is for multispectral data reconstruction. So basically, you can process the multispectral images taken by the Mavic 3 multispectral and then produce vegetation index maps, such as NDVI maps. So this is what DJI Terra can do, but not only these features. So we're constantly still bringing new features into the Terra software. And actually, Alex has also just touched some of them during his live demo. So here I would like to go through quickly with the latest ones. So first, we have reduced the RAM memory requirements for LiDAR data processing. So for example, with 16 gigabytes available RAM in your PC, previously, you can only process 4 gigabytes of raw point cloud data. But now it has been increased to 15 gigabytes. So I guess more 3 times increase. And on the right side, you can see here is an example. So using the 64 gigabytes RAM, you can now process 60 gigabytes of L2 data. This is an example from one of our clients in China. This is actually a data set of, I guess, about 11 flights. So potentially by processing those flights of data together, you can, avoid issues like, in the edge of different flights, and you can merge them better and align them in a better way. So the other thing I think Alex has also demonstrated just now is that you're now able to create contour lines in DJI Terra as well. So, previously in DJI Terra, in the previous firm updates, we have introduced features like ground point classification. Right now, you can divide or separate the points into ground points and others. And based on that, you can generate the DEM. And we've now gone one step ahead to create the contour lines. So right on the right side, you can see an example of the contour line and DEM overlay. This is shown in the Terra quality report. And also the contour line file can be found in the Terra project folders in DXF or SHP formats. The other thing, which is also a really handy feature, is the vertical profile tool. So basically, you can draw a cross-section and being able to display the grid lines and see and conduct like point or distance measurement. For example, like measuring the tree height or the slope of a surface like this. And just one last thing, work with DJI Modify. Like I mentioned, DJI Modify is our new tool to allow you to do some, basically to beautify or retouch a 3D mesh model that you have created with DJI Terra. So basically in DJI Terra interface right now, you can see there is an option or button called the Work with DJI Modify. if you turn this on and you process the photogrammetry model in DJI Terra, you can just use one click to open the same model in DJI Modify and do the retouching, like I mentioned, removing the vehicles or hole patching and so on. So, and the other thing that you can look forward to is like we're also going to support a new feature like by sharing via a web link. So basically in DJI Modify, you can share the retouched model with a web link. I think this is something that a lot of people have been asking for, you know, to being able to quickly share a model to someone else in your team, you know, and they don't have to install a software like DJI Terra. They just need to open the web link. So also a pretty handy feature that we're going to provide, hopefully in maybe April or May. And this is not a new feature. It is something that we've also got some questions on. So especially for certain construction projects, sometimes it requires the deliverables to be in a local coordinate system. So how to do that, how to get the results in the local coordinate system in DJI Terra. There are a few ways that we would like to recommend. First, you can use the 7-parameter transformation tool in Terra. So when you define the output coordinate system of the result, you can see here there is an icon on the right side of the arbitrary coordinate system. It will allow you to define the 7 meters to make the transformation. And this is one way. On the other hand, you can definitely also set GCPs within under the local coordinate system, and by implementing the GCPs, you can correct the model or align the model with the local coordinate system. And the third way is like you can also transform the coordinate system with a third-party software by exporting the the image position data, and then you can do the transformation with the third-party software, and then import the pose back into the Terra software again, and then do the processing. So basically, these are the ways that you can use to generate the results within the local coordinate system. So pretty much for the features in Terra, so for those who also are new to DJI Terra, basically you can simply find the DJI Terra software installation package on our DJI website, or you can just search maybe DJI Terra in the Google, and then you can find the link. And if you are interested in testing DJI Terra, you can just take a few minutes to do a quick survey after this webinar, and we can send a 1-month trial code license for DJI Terra to you. So this survey will be launched immediately after the webinar, and also will be sent in a separate email. Okay, so I guess that's pretty much from my side right now. And let's see if we got any other questions from the audience. Alex, maybe you can take this one. There is a question from Alexandra. Have a software to compare 2-point clouds and identify if there is a modification.
Right. I'm not too certain about that with DJI Terra. I think that would be probably something you'd want to do in Terasolid. I'm not 100% sure on that, but we might have to look into that one. It may be worth kind of dropping us an email about that. We haven't had that come up previously. Just trying to think if there's a way to, I mean, I presume you're looking for a sort of table or something to show you the differences. But I would imagine that would be a feature of Terasolid, but I'm not 100% certain.
Yeah, and to add on to that, on my side, first this is not yet available in DJI Terra, but we're interested in doing something more, like analytics related feature in Terra definitely. But right now, as I know, I think it's available in Cloud Compare also. I mean, if you want to just compare two point cloud model and like calculate the volumetric difference based on the two models. So maybe also, yeah, available in some other software like Alex mentioned. And okay. The next question, will there be a way to update the base station coordinates for imagery, not LiDAR? Okay, so as I understand, you're possibly asking also about the PPK workflow for the photogrammetry processing, because as I understand, there is a way to do the PPK processing directly for LiDAR right now in Terra, and you can also adjust the base station center coordinate. However, right now it's true that we don't have the complete PPK workflow integrated into the DJI Terra software, but I guess we have some recommendation on the workflow with other third-party software on our blogs on the enterprise page. So yeah, it also requires a third-party software right now. So also, I'm not sure do you have any other recommendations, Alex, on the photogrammetry PPK workflow?
So am I right in saying that this would be for just doing 3D meshes with photogrammetry rather than the LiDAR? Because you can select your GCPs when you import them. So Terra will give you the option to like look at the photos where it's picked up a ground control marker, and you can select the center of those to align your model when you're doing photogrammetry. But yeah, that's in terms of LiDAR, yeah, the X and Y sort of alignment can't be done in Terra just yet.
Mm-hmm. Yeah, that's true. Okay, the other question from Philip, what does Terra Photo do? Because I think it's interesting, like we have a similar name with Terasolid. I'm not sure, is it talking about a Terasolid?
Yeah.
Okay, then maybe you can answer that.
So Terra Photo is not something that I tend to use. The other features of Terasolid, with particularly Terrascan, is where most of our work gets done, with the wizard there that helps with sort of noise and matching passes and things like that. So I might again have to look into that one afterwards, and maybe worth dropping us an email after the webinar, and we can have a look into that for you. Quite often our clients tend to buy the package where you get the Terra Match modeler and scan, and actually might miss off Terra Photo. So that's something we can look into afterwards if you want.
Sure. Okay, next question. How can we get a sample data set of L2 in forestry mapping? So for this one, we have a few data sets for L2, and so from this question from Danilo, I can send it later to you after the webinar. And next one, if a process LAS file from Terra is corrected using ntrip workflow, will it line up with Civil 3D or AutoCAD when the point cloud is imported? Yes, that's what I would assume.
Yeah, I'd agree with that. If you're using ntrip with your flight, then yeah, you should find that it is lined up with coordinate systems, and that helps with importing it into any other software and lining it up with any other data you've got. So yeah, I would say so.
Mm-hmm. Yeah. Okay, and you mentioned the L2 footprint is smaller. What is the size of the footprint, let's say 100 meters away? As I remember, it is about the size of a mobile phone. I think we have the detailed specs on the official website, and let me try to pull it up maybe. Just 1 second. So the laser spot size is horizontal 4 centimeters by vertical 12 centimeters at 100 meters away. And this is the FWHM. Okay, next question. I would like to analyze and test the deep data processed in Terasolid. I'm not sure what this question means. So if you have further clarifications, feel free to drop that again in the question box. And the next question, sorry?
I was just going to say, Terasolid they do have a trial available through their website that you might want to try that out if you want to test out any data in that. So yeah, if you just go through Terasolid's website, you should be able to get a trial of the software.
Sure. The other question from Robert, can you explain briefly how this could be used in agriculture to provide insights into crop management, crop health, or agronomy? So as I understand, maybe still the RGB and the multispectral data would be more useful for the agriculture. What do you think, Alex?
Yeah, I'd definitely say that you'd be looking at multispectral data for that kind of information rather than LiDAR. LiDAR will get you sort of measurements of it'll get through the crop surface and it'll get to the ground, and you'll be able to see physical measurements of the crops. But if you really want to look at crop health, and you want to be looking at things like vegetation indexes, which is what the multispectral data will give you. So yeah.
Great. And the next question is about more on the commercial side. Can you outline the software cost options? Is it per user, or can it be on a server with multiple users? Is it annual, or there is a perpetual option? So in general, yes, we first, the Terra software is a PC software, because I also see someone asking, does it work on MacBook Pro? I'm afraid it only works on Windows PC right now. So we do offer both annual licenses as well as the perpetual options. But for the perpetual options, it's like you still need to pay like a software upgrade fee after 1 year period if you would like to update to the latest version to enjoy the new features. So there are different options, but also because the detailed pricing is different in different country. So if you're interested in purchasing it, yeah, potentially you can also let us know or drop us an email after the webinars. Okay, and yeah, I saw questions from Tobias. Terra also works on MacBook Pro. I'm sorry, we don't have the Mac version right now, so still it's right now only working for Windows software. And yes, it requires a NVIDIA graphics card because for the, like for example, for the geometry reconstruction, it has you know, like a high requirement on the GPU side. Another question from Helmes, is there any plan to improve the terrain or ground point classifier in areas with a lot of vegetation or very steep slopes? Because Terra falls somewhat short on this. Yeah, I mean, in general, we do have plans to improve, you know, the features of Terra software, because, for example, like in recent updates, we improved the way that Terra handles the noise reduction and the smooth point cloud feature. So yes, in general, we would like to improve that. And if you have any specific issues, you can also feel free to contact us or our support team so that we can do the troubleshooting for the specific issues. I guess that's pretty much all the questions.
Okay.
Okay, great. If there are not any new questions, I guess that will be the end of our presentation today. And also just, I think one last thing, if you're interested in, you know, testing the DJI Terra software, please, you can just complete the survey after the webinar and we will send you like a 1-month trial code afterwards. And also, if you have any questions for Alex or for the Heliguy team, I think you can also reach out to them by email. Alex, I'm not sure you have shared your email in the slide somewhere.
I haven't actually, but I can, yeah. If you want to drop any emails through to us at Heliguy, if you reach out to info@heliguy.com, we'll pick that up and try and answer your queries on that. If there's anything, particularly, you know, the questions that I wasn't able to answer there, it may be worth sending those through to us and we can have a look into that.
Great. All right, then hopefully, yeah, if we don't have any questions right now, so thank you all for joining the webinar today, and thanks a lot, Alex, for sharing the case studies and also presenting the live demos and answering the questions. It's really, I hope it's really also very useful, at least from my side, and I hope the audience have enjoyed the webinar. Thank you.
Great. All right.
Have a nice...
Thanks, guys.
Mm-hmm.